Let's say you're a researcher, you have a question. So how do they typically come about saying, I'm going to use a structural equation model? And when they decide to use one, what software do they use and how do they do that?
Well, ideally, they would make that decision based on whether they need to make adjustments for measurement error. I think that's really the main reason to use structural equation models is when you have measurement error in your data, so you have less than perfect reliability and you have multiple indicators at your disposal, and so you want to correct for error so that the structural relationships will be estimated with less bias, because we know from regression analysis that one assumption of regression analysis is that the predictors are measured without error, which in psychology is never true. So the X variables, they will certainly contain, most of them will contain some amount of measurement error, especially when you have questionnaire scores or test scores or something like that. And so then if you don't correct for error, then the coefficients in the regression model can be biased, the standard errors can be biased, the inference, statistical inference can be biased, so meaning tests of significance. And so to correct for that, people use structural equation models. And then also, because they have more flexibility over regression analysis, they are multivariate, so they can use multiple outcome variables, they can have mediating variables, moderating variables, they can be fit longitudinally, they can be fit with multiple groups, they can be fit to multi-level data. If you have hierarchical data, we can use multi-level SEM. And so they are very, very flexible. And that's a reason also why people use them. And so hopefully that would be the reason. Sometimes I think that some reason is to impress reviewers. So some people will fit a fancy structural equation model because they think then they have a better chance of publishing their results. And that really shouldn't be the reason to fit those sorts of models, but it should be to improve on your outcomes, meaning correct for unreliability and fit the most flexible possible statistical model that will give you a good answer to your questions. And then there's a variety of commercial and free packages now available to fit these models. So for example, there's M+, there's AMOS, Lisrel, EQS, those are commercial programs. And then within the R statistical environment, there's Lavaan, which is very frequently used for fitting structural equation models, the Lavaan package. There's also a Lavaan GUI now online where you don't even have to open R. You can just go and search for Lavaan GUI, GUI, and then you can draw a path diagram, and it'll run your model from the path diagram that you draw online using the Lavaan package in the background, and you don't even have to mess with syntax. So that is great. And then there's also OpenMX in R as a package for fitting these models. So it's widely available now. Also, there are even like in point and click software, like JASP has basic capabilities for fitting confirmatory factor analysis and also structural equation models using Lavaan in the background. So there's a lot of tools available for fitting those.